Alright guys, welcome back to our last experiment, experiment number 10, the gas loss experiment. There's just one thing that I wanted to touch base with everybody before I actually get started. The thing is, so this is our last experiment. This is going to be due on Friday. And let me just grab the date of Friday for you guys. It's going to be April 24th. However, because it is due a little bit sooner, and this is just to make sure that we can get all the grades and things to Christine, just so that all the professors have the grades that they need, we are not having you guys do a full lab report. So for this lab, you need to do the calculations based on the data that we're giving you. And if there's not all 3 trials or anything like that, just do the trials that you're given. In addition to those post-lab questions. So those are the 2 things that we need to have you guys do. So if you could submit those as your post-lab, that's fantastic. So just to review, this means that you do not have to do the introduction, the protocol, the results discussion, any of that. We just need to do your calculations and your post-lab questions. So just a quick thing, this whole basis of this experiment is going to be that when magnesium solid comes in contact with H+ aqueous, and this is from an acid such as HCl, it's going to make the magnesium cation, aqueous, as well as hydrogen gas. So in this experiment, we're actually going to be able to collect the hydrogen gas to actually be able to determine the molecular weight of the magnesium metal. And how we're going to do this is we actually use a eudometer. So the lab setup, as you'll see in Travis's lab video, has the ring stand, it has a burette clamp, which I'm just going to, this is my wonderful take on a burette clamp. And for this particular experiment, we have a eudometer. Now, a eudometer kind of looks like a big old test tube, but it's actually measured from the 0 being here, and then it increases in volume here. And the reason that we're doing this is a eudometer allows us to measure a gas volume, such as our hydrogen gas in this particular experiment. So what we'll notice is we're going to actually, so the beginning of this experiment we have a stopper, and what we're actually going to end up doing is we're going to create this cage around this little piece of magnesium metal. So this magnesium metal, when it comes in contact with this HCl, which is more dense than water, which is why we're putting it in first, is going, when we flip this, is going to slowly dissolve away that metal. So in our actual setup, what it will look like is we'll have the eudometer flipped, and this will be flipped into a beaker. So I'm just going to draw the beaker like this. And I'm just going to draw, that'll be my stopper. This is my copper wire, because copper wire is not going to interact, and I'm just going to draw my magnesium metal just like that. And what's going to happen is we're going to have that metal, or the HCl, come down, interact, which is going to produce these bubbles, and it's going to produce an amount of gas. So I'm just going to, we're going to just assume that this much gas is produced, and it doesn't actually matter how much is produced right now. But there's a couple of different things that the data actually shows us. There's the height of the water difference, and the height of the water difference, if we're thinking about it, there's going to be some sort of water in this beaker. The height of the water difference is the difference between this water and the water that is in the beaker. And this is also known as P liquid, and this will be important for your calculation section. This amount is going to be the total gas collected, which actually ends up helping us determine what that P total is, because we know the total pressure is going to be equal to the pressure of the hydrogen gas plus the pressure of the H2O. So the pressure of the H2O is coming about by this force, and the pressure of the H2O is the pressure that is created in the iodometer based on that hydrogen gas. We'll be able to determine this by doing the pressure of the barometric pressure, which will be given, minus that pressure of the liquid, which we know by the height of the water difference. And I'll walk through in the calculation section how to actually determine what this is. If you do want to look a little bit more in depth of what does this iodometer actually look like, there's a nice picture on, it's an experiment 10, page number 3 of that manual online. Just a couple other things that we want to keep in mind is there's going to be a couple of different conversions. We want to make sure that we can go from bars to atmospheres or ATM. We also know inches of mercury is one that we might come in contact with. And there's actually common pressure units on page number 4 of the lab manual if you want to take a look at that. The one other thing that I did want to mention for this lab, and I'll talk to Megan about this actually being given for you guys, is going to be the vapor pressure based on liquid water. So the temperature of water is actually going to impact the water pressure. And it doesn't, so if we look at this chart, about 20 degrees Celsius is going to give us 17.552 torr. And if we go up to, let's say, 24 degrees Celsius, so that's a 4-degree difference, 22.379 torr. So there is a small difference on this temperature change, but just keep that in mind when you're kind of going through this. So that is all I have for you guys for the actual pre-lab chat. I'm going to get into a little bit more of the nitty-gritty, go through the calculations in your next video.